Okay, back to this schematic review of the McGrath Mini amplifier audio circuitry here. So, moving on to the next section, that's the M section. Of course, I'm not trying to step on anybody's copyrights, but we all know what M stands for here. I think, in particular, this is a M of type 2204 or 2203. That is the late 1970s to mid 1980s type of Marshall lead amplifier, but it's modified a bit. So you can see this is pure Marshall input gain control here with all the bright caps. It's a very bright stage, bright cap around this voltage divider as well. So this is all straight up Marshall design here. However, this is called the cold clipper section here. Marshall uses a 10K. I'm using a 39K, which is borrowed from Soldano amps. The rest is straight from Marshall. So if Mike Soldano modified some other stuff along with putting that 39K, I have not carried that over, so I've got kind of maybe a hybrid between the two. Who knows? But it does sound good. But bigger changes are down here because of the FX loop turning out to require a stage of a triode that I didn't want to have to use before. I had to steal one of the three triodes from the original M section, because right after this stage, this is pure Marshall, instead of this capacitor, it should go into a cathode follower stage directly and then drive the tone stack with that. But I removed that cathode follower and replaced it with this capacitor, which is maybe not such a good idea. But I will say it still works fine. So my basic theorem that the Marshall section would still get the same basic tone without that cathode follower being there does seem to be true. However, I think I need to use high voltage rated caps here for these three and get rid of this spurious cap that I added just kind of mindlessly as I was combining sections, because in the Fender style of tone stack, of course, these would be the voltage blocking caps as well as the tone caps, and there would be no cap here, and that's going to get it closer to what the Marshall circuit was as well. So I should probably try that. Right now I'm getting a very thin and trebly sound out of this M section, which is really what I wanted anyway, but I suspect it's more than should be because of this cap. This cap will be combining with these other caps in series and leading to higher corner frequencies, lower capacitance overall in the tone stack than it's supposed to have. So that's a change I will probably make at some point. Moving on, here's this FX loop where I had to use this stage. So what happened here, I was originally just going to have a passive insertion point where instead of send and return jacks, it would be a preamp out and power amp in jack just running at the full level of the amp. That's what I marked the panel for originally. That's the way Dumble does it and others to avoid this problem. But I really need to have an actual functional FX loop on this amp that works with solid state gear such as my digital reverb unit, and therefore it has to have this little section where the signal level drops down to transistor level and then gets boosted back up. And because I only had one section to do it all with, unfortunately the FX loop is inverting when it's engaged, and it's really not perfectly transparent on sound. It changes the sound a little bit, and so I put a full bypass switch in it so the whole mess can be removed from the circuit when it's not being used, and flipping this switch up and down even when there's nothing plugged into the jacks, you can hear a little bit of a change, partially because of the phase flipping, but also the tonality changes a little. So it's not perfectly transparent, but it does have the necessary gain to actually handle effects properly, which the raw insert point did not have. And I would have had to add some external amplifier circuit like Dumble had to do, and that was not acceptable. I needed this amp to be a one-stop solution, so that's what I got, a kind of compromised, functional but compromised effects loop and a bypass switch for when I don't want that compromise in the circuit. Anyway, there it goes, right to the volume control, EL84, no negative feedback, single-ended Class A power amp. This is all pretty much boilerplate circuitry from various sources on the internet. I didn't make any special changes here, really, to speak of. So that's about it for the audio circuitry that I wanted to talk about. Now, taking a look at the power section here, a couple things I wanted to touch on. This resistor right here is very important. It connects gives the heater system a reference to ground, and that drops a whole lot of hum. When I first built it, there was no connection there. This was just floating just to see what would happen, and what happens is there was too much hum. The AX84 and other designs online connect this to a higher voltage point, and there's various theoretical reasons why that might be a better idea. In practice, I tried it at the higher voltage point and at ground, and there is no discernible difference. They both killed that hum in just the same way, and so I went with a simple connection straight to ground and not to the power tube cathode, which seems like it could have other bad ramifications, so I don't know. But anyway, so there's that. Here, this Hammond Transformer has a higher and a lower voltage tap for the input side, and I am connected to the higher voltage tap. In other words, I'm running things at a slightly lower voltage, a little less hot than I could if I used the other tap there, and that's on purpose, all part of the design to make a very saggy power supply. I'm also using a tube rectifier as opposed to solid state for the same reason, to get that tube sag. And then all of the high voltage circuitry here, as you can see, everything first has to go through this rather large 1K power resistor before it hits any capacitors or anything. And that is that's a sag resistor would be the name for it, and it does that to the power supply. It's a very saggy power supply by design. You can see this is my as-built. I'd probably have a single, say, 100 microfarad cap here in future iterations of this amp, but this is what I actually had to put. I started with a 22, had too much hum. After I fixed this hum problem, I still had some residual hum from this single-ended power supply design. There's no hum cancellation, so added 147, that cut it down. Tried another and it cut it down asymptotically a little bit more, so I figured this is total value, good value there. You can see the heaters. I played that game of swapping the heater phases on alternating tubes. I don't know if it makes a difference or not, but that's how I wired it. So that's the story on the power circuitry. Let's see, anything I wanted to say here? Just as noted in the notes, my foot switch uses orange LEDs. It would work if there were no LEDs at all, just switching directly to ground, but you couldn't use blue LEDs because the voltage drop across a blue LED is too high, 3.7 volts, and the reference on these comparators is 3.4, so that's a subtle point to be aware of there for anyone building and modifying this thing. The quickest fix, if I did want to use blue LEDs, is I'd probably just change to 12 volt rails instead of 5 volts, and all such problems would go away. So that's your schematic review for now, y'all.